The announcement of Russia's Marker combat robot deployment underscores a new chapter in autonomous warfare. Following the decision by the United States and Germany to supply Ukraine with advanced battle tanks, specifically the Leopard 2 and M1 Abrams, Russia swiftly responded with promises of a new countermeasure. Dmitry Rogozin, former head of Roscosmos, disclosed plans to field the Marker combat robot to neutralize these Western tank systems. The deployment, expected to begin in early 2023, highlights a shift from traditional warfare to one where autonomous, AI-enabled robots take on frontline roles. Unlike earlier generations of unmanned ground vehicles, UGVs, which largely focused on reconnaissance or logistical support, the Marker's design combines autonomous movement with highly sophisticated targeting capabilities, specifically aimed at countering NATO-supplied assets. The development of Russia's Marker UGV, unmanned ground vehicle, exemplifies a significant leap in combat robotics, blending modular design, AI-driven vision, and advanced mobility. Its creation was a collaboration between the Android Technique Company and Russia's Advanced Research Foundation, organizations that specialize in cutting-edge military technology. Marker is specifically designed to operate in diverse combat environments, and its 3-ton structure, supported by a tank-like tracked chassis, is a testament to its durability and adaptability across various terrains. The modular design of the Marker allows for flexibility in weaponry configurations. This adaptability means operators can equip the robot with an array of weapons, including anti-tank missiles, grenade launchers, and heavy machine guns. These configurations enable the Marker to effectively engage a wide range of threats, from armored vehicles to infantry units. The modularity also serves a strategic function, as it allows for quick adjustments and upgrades, meaning that the Marker can be optimized based on evolving battlefield requirements. What sets the Marker apart is its multispectral vision system, which incorporates a blend of visual and infrared imaging capabilities. This system is enhanced by neural networks that process data in real time, allowing the robot to perform autonomous target identification and selection. The AI algorithms employed in the Marker enable it to analyze imagery and sensor data instantly, a capability that is crucial in dynamic combat environments. The robot can distinguish between allies and enemies under varying visibility conditions, such as in smoke, fog, or nighttime settings. This multispectral vision, coupled with advanced AI-driven recognition, equips the Marker to identify specific targets, such as Abrams and Leopard tanks, and swiftly respond to perceived threats. The AI-driven prioritization system in Russia's Marker UGV is designed to function almost as an autonomous decision-maker on the battlefield. This capability enables it not only to recognize enemy equipment, but also to evaluate and rank each target based on perceived threat levels. Such prioritization is crucial for efficiently engaging high-stakes assets like NATO-supplied Leopard 2 and Abrams tanks, which are some of the most advanced in modern warfare. By assessing each target in real time, the Marker can quickly identify which assets pose the greatest immediate threat to Russian positions and adjust its engagement strategy accordingly. This assessment process relies on the robot's extensive catalog of threat profiles, which includes visual, infrared, and other identifying characteristics of various enemy vehicles and equipment. Once a target enters the robot's operational range, the onboard AI immediately matches the sighted target with entries in its catalog. This instant comparison allows the Marker to engage strategically, focusing its most powerful weapons on high-priority threats while potentially disregarding lower-risk targets or vehicles that do not pose a direct threat. The integration of this AI-based prioritization capability is especially relevant in high-intensity conflicts, as it can lead to faster response times and more precise targeting than human-operated systems. In addition to engaging priority targets autonomously, the robot can continuously update its targeting hierarchy, reacting dynamically to shifting battlefield conditions, such as the arrival of new, more threatening assets or the withdrawal of lower-priority targets. This adaptive capability not only minimizes the likelihood of unnecessary engagements, but also allows the Marker to conserve resources by only using weaponry that is proportional to the threat, optimizing its impact and endurance in prolonged engagements. Beyond its physical capabilities, the marker's autonomy and target selection and engagement is a game changer in the field of combat robotics. Equipped with an extensive digital catalog of enemy assets, the marker robot can independently choose its targets based on threat levels. Rogozin explained that the robot's control system can autonomously decide between a range of visible assets, such as tanks, armored vehicles, and personnel carriers, without human intervention. For instance, if the marker encounters a T-64 tank, an armored personnel carrier, and a Leopard 2 tank on the battlefield, it will automatically prioritize the Leopard 2 based on the threat hierarchy programmed into its AI system. This capability to discern and prioritize critical targets is enabled by the combination of its multispectral imaging and data-driven neural network processing, which collectively contribute to a highly autonomous and lethal combat system. Since Marker's initial development, Russia has anticipated its application as a testing ground for future second-generation combat robots. Unlike prototypes that typically remain in controlled environments, Marker has been deployed in actual conflict zones, most notably in Syria, where it supported Russian troops by performing reconnaissance and limited engagement tasks. However, its role in Ukraine is expected to be markedly different, as it will serve as a direct combat tool against heavily fortified targets. Russia's prior use of robots in Syria laid the groundwork for Marker's development, with the experience informing Marker's enhanced mobility, target acquisition, and engagement capabilities. The robot's modular design allows Russia to continually upgrade its arsenal, integrating the latest in weapon technology and AI software. The decision to deploy Marker in Ukraine aligns with broader Russian military strategies. While traditional weapons remain a staple in Russia's arsenal, the use of autonomous systems enables the military to minimize personnel losses and conduct operations in high-risk areas with less immediate human intervention. In the context of the Ukraine conflict, Marker represents a response to NATO's influence on Ukrainian military capabilities. By deploying a combat-ready autonomous robot, Russia signals its willingness to match the technological escalation brought on by Western military support. Kremlin officials, including Dmitry Peskov, echoed this sentiment, emphasizing that Western tanks sent to Ukraine would burn like all the rest. The arrival of Leopard and Abrams tanks has escalated the conflict, prompting Moscow to showcase its technical prowess and send a message to the international community regarding the capabilities of its defense industry. Marker's entry into combat may also have broader implications for the international community, as it raises ethical and strategic questions about the use of autonomous weapons. Autonomous systems like Marker blur the line between human and machine decision-making on the battlefield, leading to concerns about accountability and control. For instance, if Marker were to misidentify a target or engage in unintended collateral damage, determining liability becomes complex. International bodies, including the United Nations, have called for regulatory frameworks to address the ethical considerations surrounding autonomous weapons. The deployment of Marker could accelerate discussions on this front, investments in autonomous weapons by other nations. As autonomous systems continue to develop, they may fundamentally alter the nature of warfare. Unlike human soldiers, machines like Marker operate without fatigue, fear, or hesitation, which could potentially lead to prolonged and more intense conflicts. Moreover, the deployment of robots on the battlefield might encourage nations to engage in proxy wars, where machines do the fighting while minimizing direct human costs. Autonomous weapons could redefine combat tactics as military strategists incorporate AI-driven systems capable of real-time data analysis, target prioritization, and mission adaptation. The impact of these advancements is likely to be felt not only in Ukraine, but also in future global conflicts, as other countries develop or acquire similar technologies. The deployment of the Marker robot also reflects Russia's broader reliance on technology as a force multiplier. In recent years, Russia has sought to compensate for manpower shortages by investing in high-tech solutions, ranging from cyber warfare capabilities to advanced missile systems and autonomous vehicles. In the Ukrainian context, Marker serves as a powerful tool for asymmetric warfare, allowing Russia to confront technologically superior Western assets with minimal human intervention. This approach is part of a larger trend among global military powers, where unmanned systems are increasingly deployed alongside traditional forces. In the United States, for instance, the Department of Defense has invested heavily in autonomous platforms for surveillance, reconnaissance, and strike missions, as well as in AI algorithms designed to assist human operators in decision-making. Marker's performance in Ukraine will serve as a litmus test for the viability of autonomous weapons in modern warfare. Military experts will closely monitor the robot's effectiveness in engaging advanced Western tanks and other Ukrainian assets. Success could lead to increased investments in robotic combat systems, both within Russia and among its allies. However, if the Marker encounters significant limitations, it may prompt a re-evaluation of Russia's reliance on autonomous systems, potentially leading to adjustments in its military-industrial strategy. Additionally, the real-time application of AI on the battlefield could provide valuable data for Russia's defense research institutes, further informing the development of next-generation autonomous systems. The deployment of the Marker combat robot represents a milestone in Russia's military strategy, symbolizing a shift towards autonomous warfare that may influence future conflicts worldwide. By integrating AI into its combat systems, Russia seeks to counter the advanced military support that Ukraine has received from NATO allies, underscoring its commitment to technological innovation on the battlefield. As Marker is tested in Ukraine, its performance will likely have far-reaching implications, not only for the course of the conflict, but also for the future of autonomous weapons and global military doctrines. Thank you for watching. If you found this breakdown insightful, feel free to like, share with others interested in military technology and current events, and subscribe for more updates on evolving global conflicts and technological advancements.